angular frequency. A circle of radii r can fit these radiuses r can fit 6.28 times all the way around the circle, all the way around the circumference, if you like. So half the way round, so from here to here, would be 3.1415. 123.145 of an r. So you can recognise that that's pi. Okay, so that's how we get pi basically, because we can fit 3.14 of these radiuses halfway around a circle. So all the way around the circle obviously is 2 pi. So when we talk about 2 pi r, we're talking about 2 pi radians. Okay, the radian r is generally written as this, which is phi with a little c on the top, where c means circular measure. So if you see that, that's referring to radians. Now let's say, as an example, it takes 2 seconds to traverse all the way around 2 pi. So it's going to take 2 seconds to go 1 complete revolution. Then we can say that we have revolutions completing at a speed of 0.5 revolutions per second, or half a revolution per second. Now, cycles per second has the hertz as its unit and commonly referred to as frequency. The radii covered per each second is phi over t, radians over t, and that's called the angular speed. The angular speed of revolutions of circles is written as W, where W equals 2 pi f, which is 2 pi radians per cycle by the number of cycles per second. This is called angular frequency. This means we can write omega as phi over t, and that, as I said, is known as angular frequency. Right, here's a question. How many radians would we sweep through in 10 seconds when the frequency is 0.5 hertz? Have a think about that for a minute, see if you can work that one out. Maybe I want to pause it. Okay, to work this, we use omega t equals phi, which equals 2 pi f t, which is in, when you cancel out the units, you're left with radians. So that becomes 2 pi times 0.5 times 10, which is 2 pi times 5 radians, as I've got here. This means, in words, we will have revolved around the whole circle 5 times. 1, 2, 3, 4, 5. And the radii swept out during that time will be 2 pi times 5. In other words, 6.28 times 5, which gives us 31.41 radians. If you want to just check that, you can, if you divide that by 2 pi, you'll find you'll get the 5 back. So this can now be summed up by writing omega t equals phi, which in words says 2 pi radians are traversed through each of the f cycles per second over the time period t. This is then equal to the total number of radians traversed. And that's it. So I just wanted to quickly go through angular frequency, be covering a bit more of in a bit more detail in some future maths refreshers.